Hey everyone, and welcome to The Explainer. Today, we're talking about some of the biggest things humans have ever built. Seriously, these structures can stop a whole river in its tracks and light up entire cities. Yep, we're diving into dams and figuring out the brilliant science that makes them work. For thousands and thousands of years, rivers really ran the show. They carved out the very land we live on, they watered our crops, and basically told us where we could and couldn't build our towns. We just had to live by their rules, because their power was just immense and totally unpredictable. But then, something shifted. We got clever. Through some really incredible engineering, we figured out how to tame that wild power. We learned how to literally press pause on a river, bottle up its energy, and make it go where we wanted it to go. We started shaping the rivers instead of the other way around. So that's the big question for today, right? How do these absolute giants of concrete and steel actually manage to tame a river's incredible force? How do they pull it off? All right, let's get right into it. So, what is a dam at its most basic? Well, think of it as a giant plug. It's a massive wall we build across a river to stop or slow down the water. And when you do that, the water starts to back up, creating this huge, man-made lake behind it. That's what we call a reservoir. And here's the thing, dams are the ultimate multitaskers. We almost never build one for just a single reason. A dam can be a flood shield, a water tap for our cities, a power plant, and a vacation spot all rolled into one. It's pretty incredible. Okay, so let's zoom in on that electricity part, because hydropower is a huge deal. How in the world does a giant slab of concrete turn flowing water into the juice that powers your phone or your TV? Let's break it down. All right, this is the key. You gotta think of that huge reservoir behind the dam as a giant water-powered battery. Now, it's not storing electricity like a normal battery, it's storing potential energy. By holding all that water way up high, it's just full of potential. The higher the water is stacked up, that height difference is called the head, the more power is packed into that battery. And that energy gets unlocked in a really cool three-step process. It's all about converting energy from one form to another, turning that stored water power into actual electricity. Okay, step one, a gate opens up deep in the dam and whoosh, water starts rushing into this enormous pipe called a penstock. As it barrels down that pipe, all that stored up potential energy gets converted into pure kinetic energy. We're talking the energy of motion, and it's moving fast. Then, at the bottom, that super fast jet of water just slams into the blades of a turbine. Picture a massive, high-tech water wheel, or a giant propeller. The sheer force of that water gets the turbine spinning like crazy. And just like that, the kinetic energy of the water has become mechanical energy, the energy of spinning. And for the final step, that spinning turbine is hooked up to a generator. As the turbine spins, it turns the generator. And inside, a bunch of magnets work their magic, turning that spinning motion into electricity. And boom, that's it. We've got power. So what happens to the water? Well, after it's done its job spinning the turbine, it just flows out through a channel and heads back into the river downstream, a little calmer than before. Its energy has been harvested and is already on its way to our homes. But like we said before, making electricity is just one of the dam's many jobs. There's a lot more to the story. That reservoir is a total game changer. It can soak up huge amounts of floodwater from a big storm and then release it nice and slow. It's a reliable water faucet for our cities and farms. It makes it possible to grow food in dry places. It can even make rivers deep enough for big ships to pass through. It does a lot. But, and this is a big but, all these amazing benefits don't come for free. You can't just drop a giant wall in the middle of a river and not expect some major consequences. There's a real trade-off here. And this really lays out the two sides of the coin. On the one hand, you've got all these pros. Clean power, tons of water, safety from floods. Awesome. But on the other hand, you have some serious cons. Fish can't swim upstream anymore, entire ecosystems get flooded, and people are forced to leave their homes. And that human impact, that's one of the toughest parts to swallow. When you build a dam, you create a giant lake, but that lake floods a valley that was once home to people. We're talking about an estimated 40 to 80 million people worldwide who've had to leave their homes because of dam construction. Their towns, their farms, their history, all just gone, underwater. Okay, that was a lot to take in, so let's do a quick recap. Here are the 5 key things you really need to remember about dams. Number 1, dams are energy transformers. Their whole magic trick is turning the stored energy of high-up water into the electricity we use every single day.
Number 2, it's all about the height. The power of a dam comes from how far the water has to fall. That's called the head. The bigger the drop, the more power you get. Simple as that.
Number 3, they're more than just power plants. Remember, dams wear many hats. They control floods, they supply water. For millions of people, they're an absolutely critical piece of modern life. Number 4, there's always a trade-off. Every single dam is a balancing act. You get these huge benefits, but they come with real environmental and social costs that have to be weighed very, very carefully. And finally, number 5, dams have literally changed the world. For better or worse, these massive structures are one of the biggest ways humans have ever reshaped the planet. There's almost nothing else like them. So that leaves us with a huge question, doesn't it? Our world needs more clean energy and more fresh water than ever before. So how are we going to balance the incredible power of these giants with the need to protect our natural world? The story of dams, well, it's definitely not over. Thanks for joining me for this explainer.